Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the different types of data and data visualization. So, very first thing is you may know that. So, what is the data? So, data is nothing but anywhere it should be available. But exactly the data is that it should be a collection of facts such as numbers, words, measurements, observations, or even just descriptions of the things. There may be a software in the market, so it should be also helpful to identify the type of data, and then it should be important for the at least for basic understanding of different types of the data as well. So in the article you may have already know that what should be the different types of data we have. So the data is nothing but a collection of facts such as numbers, words, and it should be a measurement of form, or it may be in the form of observation, or even just description of the things. So some of the softwares may also be available in the market to analyze the data, and then what are the different types of data. So normally the data may be of different types, and which may be come from different sources like primary and secondary sources as well. And the types also be classified into different types like qualitative data and then quantitative data. So that's then I'm going to discuss all the things. So normally the data may be in the form of a string, or it may be in the form of a number, or it may be in the form of a boolean. It should be of the type true or false. And then I can also be say that the data may be in the form of an array, or it may be in the form of objective. So object is nothing but a real world entity, or it may be the form of date, bytes, file, and then null type. So these are the different types of data we have, and how the data, what we collected in the form of facts, or it may be in the form of a measurement, or it may be in the form of observation, or even just description of the things. So that thing we should be called as a data here. And then some of the types of data also be done, so like qualitative and quantitative, and it should also be helpful in understanding different types of the data as well. When it comes to the types of the data, so normally the types will be of interval, ordinal, and nominal. So these are the other kinds of the data. So like the interval means that it should be in a defined constant, which should be of a difference between the different levels of data. And ordinal means it should be the hierarchical structure to the levels of data, but the difference between them, it should be either in the undefined form, or it should be in the form of a variable. And there should be no hierarchy in the hash structure, or no order in the size of the values. So interval means that there should be the defined constant which should be exist between the different levels of the data as well. And ordinal means that it should be in the hierarchical structure, but the difference between the levels should be either undefined or the variable. So nominally, there should be no hierarchical structure is going to maintain in nominal data. That means that no order in the size of the values here. So normally the types will be of two types. What I said should be the quantitative data and then qualitative data. So it should be also be treated as a categorical one. So again, this quantitative data will be of the type discrete and continuous, whereas this qualitative should be of binomial, nominal, and ordinal. So these are some of the different types of data, and again the subcategories of the qualitative and quantitative is there. So quantitative means it should be of the time continuous and discrete, and qualitative means that it should be in the form of binomial, nominal, and ordinal. So for this qualitative data, you are not going to may have any kind of measurements here. For this quantitative data, we are going to have measurements like height in centimeters and weight in kgs, like this. So continuous and discrete. So continuous means this should be the dependent on the time what we're going to be collecting the data here. So quantitative means that it should be going to have a numerical information, whereas this qualitative means that it should be of descriptive information. That means describing, categorizing something here. But here the quantitative means it should be in the form of numbers. And it also going to be deals with number the things you can able to measure objectively, such as dimensions in the form of height, width, and then length, and the temperature and humidity prices also were in the form of area and volume. And the qualitative data is going to be deals with the characteristics and the descriptors that cannot be easily measured. So sometimes it should be also in the form of like smells, taste, textures, attractiveness, and colors. So these are the some of those examples of this qualitative data. Okay, the quantitative data means that it should be of numerical information, whereas the qualitative data means it should be of descriptive information. So qualitative means there's it is going to be deals with numbers and things that can able to measure objectively, and then the dimensions such as height, weight, and length should also be considered, and temperature and humidity prices also going to be one of the examples of this quantitative data. Whereas this qualitative means that it should be able to consider the characteristics and descriptors, so that cannot be easily measured here, and such as it should be of smells, text, textures, attractiveness, and colors. And when it comes to the continuous and discrete, so the qualitative data should be in the form of either a continuous form, or it should be in the form of discrete one. So what should be this continuous and discrete here? So continuous means it should able to represent the measurements, and here can able to represent the items that can be counted here. That should be another example of main difference between the continuous and discrete. So here the continuous means it should able to represent the measurements, whereas this discrete should be able to represent the item that can be counted. For example, if you want to measure the height at progressively more precise, so then at the time what I'm going to do, I'm going to have a scale of meters, centimeters, millimeters, and beyond that. So the height is going to be continuous data. So height means, so height is what should be 1 month the height is 5.0, and then after 2 months the height is going to be increased to 5.2, after 3 months the height is increased to 5.4. So where I can able to measure all this in the form of centimeter, meters, or centimeters, whatever it may be, centimeters. So similarly, if I'm going to consider the discrete one, so here the number of males in the group. So suppose I have a population here, so I want to measure how many number of men's in this population, and how many number of women's in this population. So let it be some 10,000 men's and 5,000 women's are available in some particular village like this. So this should be another example of this descriptive data here. So if I'm going to measure the height of males in a group, then the data becomes the continuous data also. Okay, so this should be the main difference between the continuous data and the discrete data. And again, this qualitative data will be of different types, like where that it should be different of the three types, like binary and then nominal and ordinal or ordered one. So the categorical data is going to be represent these characteristics of such a person's gender, or it may be a martial status or hometown. So this and all should be considered as the qualitative data. So other synonym of this qualitative data should also be called as a categorical data. So that means I have one of the examples of this person gender, like it may be a male or it may be a female. These are not the units here. So marital status, that should be married or unmarried, and hometown. So this and all not going to maintain any types of measurements here. And categorical data can also be take a numerical value, such as 1 indicating should be the male and 2 indicating the female, but those numbers don't have a mathematical meaning. So again, this qualitative data should be of different types, like binary and then nominal, and next one is ordinal. So the binary means that it should be the data whose unit can only take two mutually exclusive categories, in accordance with the binary numerical systems and Boolean algebra like right or wrong, true or false, or accept or reject. So the binary data is the data whose unit can only take two or more exclusive categories, and in accordance with the binary number system and Boolean algebra, and right or wrong, true or false, or accept or reject form. So the nominal scales also be used for labeling, so without any quantitative values such as color of each ball in the basket and name of your school and type of card. So this and all will be the examples of the nominal one. So nominal means that, so here can able to use some scaling factor, so without any quantitative value such as the color of each ball in the basket of color and the names of our school and type of car it is. So these and all will be the examples of the nominal one. And next one is ordinal or ordered. So that means, so here the data is going to be mixes with both the numerical and categorical data here. So that means that the data is going to be fall into different categories. Example, if I'm going to take, so I'm going to rate the restaurant from a scale of 0 to 4 highest stars I want to give. That should be used the example of this ordinal data here. So the ordinal data should also be treated as the categorical one. So where the groups are going to be where the graphs and charts are going to be made. So however, unlike this categorical the categorical data, the numbers do have mathematical meaning. Suppose if you want to survey this 100 people, ask them to take a rating of the restaurant from a scale of 0 to 4. So then I have to consider the average of 100 responses with the meaning. So it should be the case of this categorical data. Okay, so here the qualitative data should be of different types. So like categorical data is under synonym, so where you can able to measure some particular characteristics of person, gender, martial status, and hometown. So these are all the examples of this qualitative one. We are going to have no measurements here. And binary data is the data whose unit can be only take two mutually exclusive categories. So either it may be in the form of Boolean or algebra, right or wrong, true or false, accept or reject. So this kind of the thing should be considered as the binary data. And nominal means that, so here is the other kind of qualitative data. That means here we're going to consider the color of each ball in the basket full of colored balls and the name of the school and type of the car. Like this, so these are now will be the examples that I'm going to be considering nominal one. And ordinal and ordered means that, so here we are going to give some rating the restaurant of a mean scale of 0 to 4. So at that time I'm going to consider the data should be in the form of ordinal one. So where I'm going to consider some order here, like grades of the student, and then places secured in any game. So these are all will be the examples of this ordinal data here. So when it comes to the description of the data, so just now I said the interval, ordinal and nominal. So what kind of measurements, what kind of measures we are going to have for measuring this internal data, ordinal data and nominal data. So for measuring this internal data, I'm going to have some of the measures of central tendency, means that mean, median, and then mode. And measures of disperse should be variance, and then standard deviation, percentile, quartile, interquartile, range, and range. Similarly, for the ordinal data, I'm going to have some of the measures of central tendency, that median and then mode, and the measures of dispersion should be the interquartile range. And nominal data, it should be only for percentage, proportions, and then mode. That means, so for every kind of the data, we're going to have some of the measures what I'm going to do. So for this also I'm going to be, so the measures, what kind of measures I'm going to be considered for this internal data. So like, so measures of central tendency means mean, median, and then mode. That means I'm going to consider mean, median, mode should be this measures of central tendency. So how the mean is going to measure here means, so I'm going to have some of the measures like this. So how the mean is going to be considered means the sum of all the values divided by n. So that should be the mean, and median means that, so what should be the middle value of this value, that should be treated as the median. And more number of occurrences, most number of occurrences of the data, so that I'm going to be considered, should be considered as the mode here. Okay, so how this mean is going to be calculated means, so if I'm going to have values like this, so totally, so the sum of xi by n, that should be 1 plus 1 plus 1, 3 plus 3 divided by 9. So I'm going to get some value. So 3 and 3 plus 6, 9, 9 plus 27. So 16, 36 by 9. So this should be the mean of this. So similarly, median means, so what should the middle element of the series, that should be considered as the median here. And mode means the most number of occurrences of the variable in the series, that is 3, so that should be the mode here. So similarly, for the measures of dispersion, so I'm going to consider the variation, the standard deviation, percentile, quartile, and interquartile range. So here the measures of dispersion will also be considered. So for that, I'm going to consider the variation, so how the variance is calculated, standard deviation, percentage, and all. So similarly, if I'm going to consider this ordinal data, so for this ordinal data also, the measures of central tendency is median and mode, and dispersion is that, so it should be the interquartile range or range. So nominal is the nominal data should be percentages, proportions of the mode. So these are some of the examples of the nominal data. So just now I said, so what should be the exact meaning of how we're going to calculate the mean, median, and mode. So how we are going to be represented visually here. So if I'm going to consider the mean here, so the average value for all the values should be treated as a mean. That means it should be strongly affected by extreme values and skew distributions. Whereas median means it should be the middlemost value of an ordered set of values. That means which is not going to be affected by the extreme values or the skew distributions. And most common value of the data set is that or it may be the higher value of highest frequency, that should be considered as the mode here. So means mean, it should be the average value of all the values. So that means it should be this strongly affected by the extreme values and skew distributions. And median is that the median is the most value of ordered set which is not going to be affected or by extreme values or skew distributions. And mode means that, so most common value of the data set or the value with the highest frequency should be considered as the mode. And suppose this should be the perfect distribution of a normal data set. That means where the curve that is obtained, so the middle point of this curve should be treated as the mean, median, and mode. Suppose if this one should be the positive direction where positively skewed distribution, so at that time it should be somewhat little bit differ. So the middle of this curve should be treated as the mean here, and then the curve in the middle of this portion of the curve should be treated as the mode, and this should be considered as the median. Similarly, if I'm going for negatively distribution, so here in negative direction also, so in the middle of the graph should be median, and this should be the mode, and left of that mode should be treated as the median here. So like this, I'm going to measure the central tendencies for the internal ordinal data as well. And when it comes to measures of dispersion, so here what should be the range? So range is nothing but the difference between the maximum and minimum value that is going to be considered. like should be the difference of maximum and minimum value, that should be the range what can able to call it as. And then variance is that, so it should be the mean of square difference of individual values from the mean. So that means, so if I'm going to be how the mean, right, so there should be the square difference, that mean value, uh, mean minus x of I whole square. So that should be the square difference of individual from the mean. And if the variance is going to be high, that means that the values are highly dispersed about the mean, and probably the data set is not reliable. So the mean should be that the square difference of the individual values from the mean should be treated as the variance. So normally all the time the variance should be low. So whenever the variance is high, then the values are not going to be that much reliable here. And next one is that standard deviation. So what should be the standard deviation? So the square root of the variance should be treated as the standard deviation. So that means mean x of I. So like this, I'm going to consider the standard deviation. And then coefficient of the variance, that means that the standard deviation which is going to be divided by mean into 100. So that means the measures of precisions of the data set should be less than 5% only. That means if the quotient of the variation, so it should be multiplied with the standard deviation by mean into 100. So this should be the measure of the precision of the data. So all the time the value should be less than 5% only. Now next one, so the standard error. So standard error means it should be the measure of VRT population. So that means it should be sample mean from the true population mean. So that means standard deviation by square root of the n. And then confidence limit is that, so mean plus or minus 1.96. So it should be also measure of precision of the data. So which is going to be estimate the population parameter from the sample statistics. So these are some of the measures of the dispersion what I can able to consider here. So standard error means should be the measure of the precision. So as where the SD, that means standard deviations of multiple samples mean from the true population mean, so it should be divided by the square root of n here. And confidence limit is that, so it should be referred as, so mean plus or minus 1.96 into standard error. So it should be also measured for the precision data set, and it should also be used to estimate the parameters from the sample statistics. Then how we are going to be do the descriptions on Excel. So normally I'm going to have, if I'm going to open this Excel, so how the mean is going to be calculated means the average of some particular row to some particular row. And similarly standard deviation, we are going to have the function like standard std dev, and median is also under kind of function have for calculating mode we are going to have. And first for calculating the first quartile of 25th, that means quartile, and under quartile, and standard deviation, and then variance like this. Then however we're going to make the descriptive in SPSS. So we're going to have a software like SPSS. So that should be, which is going to measure the descriptive statistics here. So for that, initially you are going to be insert all the interval scale variables in the variable box and click on the status tab. So you can able to get all the statistics that you want. At a minimum check also, you can able to calculate the mean, median, mode, and standard deviation also. So unlike some display, the frequency tables also not required here. So initially this is the interface of this as SPSS software. And so once you entered all the variables that you want to calculate this, so you can able to insert in the variable box. So once you here going to have some three types of options like statistics, charts, and then format. So once you click on the statistics, so we are going to have calculate this mean, or what we're going to calculate the median, or we're going to calculate mode, and then some like this I can able to do in quartiles mode. So similarly, if I'm going to have dispersion on like standard deviation, variance, range, minimum, maximum, and standard deviation means, and distribution also, what kind of distribution you want, that should be skewness or courteous like this. So this should be the predefined software we're going to have, so SPSS software. And within this I can able to calculate this descriptive statistics value very easily, so by just by inserting the variables in the variable box, and then by clicking on this the statistics tab, so you can what kind of statistics you want to know, like mean, median, quartile, and standard deviation. And similarly, if I'm going to click on this charts here, so I can able to get what kind of charts also I can able to represent for the data, like bar chart I can able to represent, or I can able to represent line chart, or I can able to dot chart like this. So similarly, I'm going to have some statistics you are going to have, and similarly this should be the output of the data set what I'm going to be inserted. So this and all also can be seen in this software here. So instead of this, if I'm going to show this uh, main data, so the inserted data can also be seen. So what are the values I'm going to be get? So these for these values, so these are the values I'm inserted, and missing also is going to be shown. So if I'm going to see that, so what should be the mean of this, and median, and then standard deviation and percentage ranges out of 25, 50, and 75 like this. So next, how we're going to define this data visualization. So this data visualization should be of different types, like exploratory and then explanatory. So exploratory means that where you can able to find the insights of the data, and then how they are going to make the conservations between data and you. And explanatory means so how this we can able to represent the present insights of the data here. That should be the different types of data visualization, exploratory and explanatory. So explanatory means presenting insights of the data, whereas explanatory means finding the insights and how we're going to make the conservations between the data here. So when it comes to this data science project life cycle, so normally we are going to have different phases of this. So very first thing, we're going to have 7 phases exactly. So very first thing should be data acquisition. So data acquisition means where we are going to be gathered the data from some different sources, like primary and secondary. So this and all are going to be stored in one unit that should be called as a data acquisition. So once the data acquisition is done, then we can able to move on to the data preparation. So how this data is going to be prepared means that, so according to the application, whether the data what we collected they should be reliable or not, according to the application we collected or not, that and all going to be see here. So once the data preparation is done, then you can able to move on to the hypothesis testing, or you can able to modeling phase. So we can able to give some structure to the data what I gathered, then that should be sent for the evaluation and interpretation. So once this evaluation and interpretation, so I can able to represent in the form of various charts or graphs like this, and so by make use of so many number of multiple iterations. And once that thing is done, then we can able to move on to the deployment here. So here the deployment, so once the preparation is done, the deployment is going to be done, and then it should be sent to the various operations, and finally you can able to make the optimization. So like this, these are the some of the phases where the data is going to be undergone. So very first thing should be data acquisition, that means acquiring the data, and preparation, so preparing the data. So the next one should be the analysis and modeling. So once the data is going to be gathered, then how we're going to be analyzed and then model, and finally we can able to send the evaluation interpretation is the final thing. And later stages will be the deployment operation and then optimization. So in the data science process, so acquiring the data, that should be a part of this data wrangling. So that should be a part of computer science. And how this exploratory and explanatory data means. So these are the filter processing of the data by make use of this mathematics, statistics, and then data mining. And for this representing the refined data, that should be done through this graphic design. And finally you can able to make the interaction of the data. So the data entire thing, this process of entire the mining the data, designing, and then interacting, so this and all will be the examples of this data science process. So what should be the explanatory data visualization? So for that we are going to have different types of approaches like classical, EDA, and then Bayesian. So classical approaches means where the problem is going to be there, and from that problem is going to be where you can able to extract the data, model, analysis, and make the conclusion. And EDA is another kind of approach, so where you can able to analyze the data from where the steps should be common like problem and data analysis and modeling here. And Bayesian is the other kind of analysis approach where you can able to make the problem, model the problem, and then where you can able to apply some distribution concepts on the data analysis. And some of the statistical approaches that I can able to apply in data visualization means, so if I'm going to consider this quantitative data, so normally some of the statistical approaches what I'm going to have should be hypothesis testing, that I can able to apply details like this, and then analysis of variance should be another kind of statistical approach we can able to implement, and point estimates and confidence intervals and least square regression like this. So these are the some of the kind of techniques I'm going to have that can be applicable on the quantitative data. And similarly the graphical representations of the data will be the scatter plots, histograms, probability plots, residual plots, box plots, and black plots. So these are the different types of data analysis I can able to apply, designing where you can able to apply different types of graphs also available for implementing this here. And these are the various ways of representing the graphical representation of the data. So very first thing should be the scatter plot, so where the data is going to be represented in the form of dots, and then histograms. How can able to represent the data in the form of histogram without any gaps between them. So already I covered some of the videos how we're going to construct this graph, scatter plot, bar chart, histogram like this, and probability plots and residual plots, and this should be the box plots, and this should be the block spots. So like this we are going to have different types of data visualization of the any kind of data if I want to present. So some of the analysis procedures also be there like testing assumptions, and then model selection, model validation, estimated selection, and relationship identification, factor, effect determination, outlier. So these are the some of the analysis, graphical analysis procedures we are going to have for testing the assumptions, for modeling the selection, what kind of model is going to valid according to the application, and then estimator selection, and then factor that is going to be determine an outlier detection also. And Ascorbate quadrate, so this is one of the application of explanatory data collection where you can able to calculate this mean, median, and how are going to calculate this intercept, slope, and then standard deviation and correlation and all. So this by make use of this data set, I can able to simply calculate the mean values, and then mean value of x, mean value of y, and how we're going to be make the relationship between two, and then how we're going to calculate the score relation of the data. So these are the some of the visuals I can gather from this explanatory data analysis, how we're going to represent this. And visual encoding the data, that means so here also the data may be two types like quantitative and categorical, so where the data should be continuous and discrete one, nominal and ordinal one. So here also I can able to represent that. And these are some of the categorical scales of line graphs. So nominal, data, ordinal, ratio scale, and interval. So these are the some various ways of representing the data for the line chart. I'm using that. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.